Python evaluation metrics, accuracy, precision, recall, F1, ROC. In this lesson, we will learn the basics of measuring how well a machine learning model works. We will use simple, real-world data and show you how to calculate the most important metrics, accuracy, precision, recall, F1 score, and ROC curves. By the end, you will know how to check your models and why these metrics matter. Running the cell now. Get ready to explore how to make your predictions better. We will start by making sure your notebook shows clean results. Warnings are not errors, but they can distract beginners. Let us filter them out before we go on. This comment shows that we are setting up our environment for learning. Here, we import the warnings library, which helps manage messages that are not errors. This line hides all warnings, so our notebook will only show results we care about. Running the cell now. If you ever want to see warnings again, you can remove or comment out this line. What does model evaluation mean? When we make a machine learning model, we do not just want to make predictions. We want to check how good those predictions are. Evaluation metrics are numbers that help us measure how well a model is making predictions. Let us see how to do this in Python. Running the cell now. Think of this as a report card for your model. Let us use the famous Titanic dataset. It shows data about people on the Titanic and whether they survived. We will use it to practice our metrics. This comment reminds us that we are starting with data setup. We import pandas so we can work with tables easily. Here, we give pandas a web link to download the Titanic data directly. We read the data into a variable named df, which stands for data frame. This line shows us how many rows and columns we have. Here is a peek at the first few rows, so you can see what kind of data we are using. Running the cell now. Looking at real data is always useful before you do anything else. Try printing the shape and preview with your own files next time. Models usually have a column to predict, called the target. In the Titanic data, survived is our target. Let us see how many survived vs did not survive. We write a comment explaining we will count how many times each class appears. This line counts how many survived and how many did not. Running the cell now. Understanding the balance of your target is important. Some metrics can behave badly if one class is much bigger than the other. Now, let us get the data ready for modeling. We will pick a few simple columns as features. We will also fill in any missing ages with the middle value, called the median. Finally, we will split our data into two pieces, one for training, and one for testing the model. We start by picking features that are easy to understand. We import the tool that lets us split our data for training and testing. Here, we keep only some columns: passenger class, age, number of siblings or spouses, and fare. This line fills in missing ages using the median, so our model will not have blank values. Now, we set y to be our target variable, survived. We split the data into training and test sets, so we can teach and then check. This line shows us how big each split is, so we know things worked. Running the cell now. Splitting your data helps make sure your model will work on new stuff, not just what it already saw. We need a model to make predictions before we can test metrics. Let us use logistic regression, a simple and popular model for yes or no problems. This is a comment to remind us of our plan, make a model. We import logistic regression from scikit-learn. We create the model and set it to try up to 200 steps if needed. We train the model using the training data. This is called fitting. Running the cell now. A model learns from data, like a student practicing sample questions. After training, your model can make guesses about people it has not seen. Let us predict who survived in our test set. Here, we predict who survived using our trained model. This line gets the predictions for all rows in the test set. Just to peek, we print the first 10 predictions. 0 means did not survive, 1 means survived. Running the cell now. Seeing your predictions helps you understand what your model is actually doing. Understanding accuracy. Accuracy is simply the percent of guesses the model got right. High accuracy is good, but sometimes it is not the whole story. Running the cell now. Let us see how to calculate accuracy next. Let us measure accuracy using a function from scikit-learn. We compare the model's guesses to the real answers. This comment reminds us what we are doing: calculate accuracy. We import a function that will do the math for us. This line gets the accuracy score by comparing our predictions to the real answers. Now we print out the answer. It tells us the percent our model is right. Running the cell now. Does this number meet your expectations for survival predictions? Try to guess if it is good based on what you see. What about precision? Precision measures how many positive predictions were actually correct. It tells us, when the model says yes, how often is it right. Running the cell now. Next, we will see how to get precision with Python. Let us check how precise our model is. Precision is key when false positives are costly, like in spam detection or medical tests. This comment reminds us we are now measuring precision. We bring in a function to help calculate it. Here we get precision by comparing actual and predicted values. We print out the result. High precision means our positive predictions are usually correct. Running the cell now. In real life, you might care more about precision when mistakes are serious. What does recall mean? Recall shows what fraction of true positives were found. It answers, out of all the real ESG cases, how many did our model catch? Running the cell now. Let us calculate recall in Python now. Now, we will see how much our model catches true positives. High recall is important when missing a true positive is costly, like in disease screening. This tells us we are focusing on recall. We import the recall_score tool. Here we see how many real positives were found by the model. Printing recall helps us know if the model misses lots of real positive cases. Running the cell now. Recall matters a lot for things like finding sick patients or faulty products. F1 score, the balance between precision and recall. F1 score is a single number that balances precision and recall. Useful when you care about both, not just one. Running the cell now. Time to see the F1 score in action. We can summarize precision and recall into one score called F1. Let us see how to compute it. This says we are working with the F1 score. We import the F1_score tool. We compute the F1 score based on our predictions. Now we print it. F1 is highest only when both precision and recall are good. Running the cell now. Try to remember, F1 score is helpful when you want a balance, not just one metric. Bonus, see all metrics at once with a classification report. Scikit-learn can show you a report with accuracy, precision, recall, and F1 score in one table. Very helpful for quick model checks. Running the cell now. Let us print out a ready-made report next. You can get a table that summarizes all metrics for each label. This helps you compare different parts of your model. We are now importing classification_report for an all-in-one look. We call the function with our predictions and real labels. We use clear names so everyone knows what is 1 and what is 0. Finally, we print out the report to compare the scores for each outcome. Running the cell now. Do you notice any big strengths or weaknesses in your model? Try making changes and see how numbers move. ROC curve, measuring separability. ROC stands for Receiver Operating Characteristic. It shows how well your model separates the classes at all possible thresholds. A perfect model makes a big elbow at the top left of the ROC plot. Running the cell now. Let us draw our ROC curve with our predictions. ROC curves help us understand how good the model is at separating the two classes. It works even if the classes are imbalanced. Let us plot the ROC curve for our predictions. We comment that we are drawing the ROC curve. We import useful tools for ROC and for measuring the area under the curve. We bring in pyplot to make charts. We get the probability scores for the positive class for each person. These lines compute the points for the ROC curve. We also get the total area under the curve, called AUC. This line starts a fresh plot. Here, we draw our ROC curve with a blue line and show the AUC in the label. This draws a dashed line where random guessing would fall, for comparison. We label the x-axis as false positive rate. We label the y-axis as true positive rate. Here is our plot title, so we know what we are seeing. We show the legend, so we know which curve is ours. Finally, this shows the plot on the screen. Running the cell now. Practice prompt, try drawing an ROC curve for a different dataset next time. Models do not have to cut at 0.5. Changing the threshold gives you different precision and recall. Let us see how precision and recall change as we adjust the cutoff. Here, we want to look at different thresholds for deciding who survived. We import NumPy for quick number work. We loop through thresholds from 0 to 1 in steps of 0.1. Here, we create new predictions using each threshold. We print the threshold with the precision and recall scores rounded for easier reading. Running the cell now. See how the trade-off works. When you make it easier to predict survived, recall might go up but precision could drop. Real-world tips for metric choice. Accuracy can be misleading if there are a lot more of one label than the other. Precision is important if false alarms are bad. Recall matters if missing real cases is a big problem. F1 score is great when you care about both. ROC curve is good for checking different cutoff points. Think about your problem before picking a metric. Running the cell now. How would you choose a metric for predicting credit card fraud or disease? Let us see what happens when we change our data just a little. We will double the fair price to see if accuracy goes up or down. In this cell, we copy the training data for a new experiment. We double the values in the fair column. We build a new model, keeping settings the same. We teach it using the updated data. Now, we make fresh predictions. Lastly, we check accuracy after our change. Running the cell now. Try editing different columns or values and see what happens to model metrics. Recap, what did you learn? You learned how to set up data and make a simple model. Measure performance with accuracy, precision, recall, F1, and ROC curve. Understand which metric to use and why. Try experiments to see how changes affect metrics. You are now ready to use these metrics in real projects. Running the cell now. Practice prompt, pick another dataset and see if your favorite metric still makes sense. Thanks for learning with us. If this helped, please subscribe to our channel for more free Python and data videos. Leave your questions or ideas in the comments below. Happy coding! Running the cell now. See you in the next lesson. Try your skills with new problems and keep improving.